Your text is already well punctuated, but I made some minor refinements for clarity, flow, and grammatical accuracy. Here's the fully punctuated version. After detecting an unusual wobble in space, astronomers were led to a new discovery in our own Milky Way, the massive stellar black hole known as Gaia BH3. This monstrous entity is located about 2,000 light-years away in the constellation of Aquila, the Eagle. Despite clickbait headlines, this distance assures us that Gaia BH3 poses no threat to our solar system. In fact, 2,000 light-years is just 2% of our galaxy's total span of 100,000 light-years. So it's safe to say this black hole won't devour Earth just yet. In fact, Gaia BH3 isn't even the closest black hole to us. That title belongs to Gaia BH1, which lurks a bit nearer at 1,500 light-years away. However, what sets Gaia BH3 apart is not its proximity but its sheer mass. It is the most massive stellar black hole yet discovered within our galaxy. This revelation came through data from a European Space Agency's Gaia mission, launched in 2013 with the goal of creating a 3D map of 1 billion stars. As researchers were reviewing the Gaia observations, they noticed a distinct wobble in one of the stars in Aquila. The movement suggested that the star was being pulled around by a black hole 33 times more massive than the Sun. To put that into perspective, consider our Sun, which weighs about 2 times 10 superscript 3 kilograms. That's 2 followed by 30 zeros, or 2 nonillion kilograms. Now, imagine a combined mass of 33 suns, compressed into an incredibly dense point in space. That's the staggering reality of Gaia BH3, a mass so large that it bends the fabric of space itself, creating the observable effects that led to its discovery. Apart from the central black hole in the Milky Way, Gaia BH3 is the heavyweight champion of known stellar black holes in our galaxy, and it ranks as the second nearest ever discovered. Further observations from a very large telescope in Chile confirm Gaia BH3's mass and the star's orbit, which circles a black hole once every 11.6 years. Measurements of BH3's companion star found no sign that it was contaminated by material from the cataclysmic supernova that likely birthed the black hole. This suggests that the black hole formed long before it trapped the companion star in its powerful gravitational field. The companion star itself is an ancient giant, believed to have originated in the first 2 billion years after the Big Bang. Its trajectory, which moves opposite to many stars in the galactic disk of the Milky Way, suggests it was part of a small galaxy that merged with the Milky Way more than 8 billion years ago. Now, the team of researchers hopes their work will allow other astronomers to study this colossal black hole and uncover more of its secrets, without having to wait for the rest of the Gaia data, set to be released in late 2025. We have only seen black holes of this mass through gravitational waves in faraway galaxies. Scientists estimate that there may be as many as 100 million stellar black holes in the Milky Way. Yet, despite their mass and the powerful forces they generate, they can be extremely difficult to detect. Most don't have companion stars that reveal their presence, making them almost invisible to us. Stellar black holes formed by the gravitational collapse of a star. That is, when massive stars die, they are the remnants of supernova explosions, which may be observed as gamma-ray bursts. These black holes are also referred to as collapsars. So, Gaia BH3 is the most massive stellar black hole in our galaxy that formed from the death of a massive star. On average, stellar black holes in our galaxy weigh about 10 times the mass of the Sun. Before the discovery of Gaia BH3, the record holder was Cygnus X1 with 21 solar masses. While Gaia BH3 is an exceptional find within our galaxy, by astronomers' standards, it is similar in mass to objects found in very distant galaxies. Scientists believe stellar black holes form from the collapse of metal-poor stars. These ancient stars, primarily composed of hydrogen and helium, the lightest and most basic elements, tend to lose less mass throughout their lifetimes. This retention of mass sets the stage for the formation of larger mass black holes at the end of their stellar life cycles. Astronomers had never found direct evidence linking high-mass black holes and metal-poor stars until they found Gaia BH3. The gravitational collapse that leads to the formation of black holes is an inevitable end for massive stars once they exhaust all nuclear fuel sources. Depending on the mass of collapsing core, the outcome could be a white dwarf, a neutron star, or even a more exotic quark star. However, if the core's mass surpasses what is known as the Tolman-Oppenheimer-Fokoff limit for neutron to generate matter, it will continue collapsing, forming a black hole. The precise upper mass limit of a neutron star before it collapses further into a black hole is not fully understood. But according to general relativity, a black hole could exist at any mass. However, there's a catch. The lower the mass, the higher the density must be for a black hole to form. In a 2020 study, astronomers observed a binary star system consisting of a giant star and its mysterious small companion. They reported that this companion is the smallest mass black hole currently known to science, just 3.3 solar masses with diameter of only 19.5 kilometers. To put this extreme density into perspective, earlier, we discussed that our Sun has a mass of about 2 nonillion kilograms, equivalent to a mass of 333,000 Earths. Now, imagine more than 1 million Earths, 1,098,900 to be exact, compressed into a sphere just 19.5 kilometers across. This extreme density shows just how mind-boggling black holes truly are, demanding further exploration into these freaks of nature. Beyond stellar black holes, observational evidence suggests two other types that dwarf them. 1. Intermediate mass black holes, found in globular clusters. 2. Supermassive black holes, found at the centers of galaxies, including our own. The process by which supermassive black holes form is not fully understood. One theory suggests they arise when massive cosmic cloud of gas and dust collapse. At the galactic center of the Milky Way lies the supermassive black hole Sagittarius A star. Situated 26,000 light-years from Earth, it contains 4.3 million times the mass of the Sun. However, even Sagittarius A asterisk pales in comparison to TON 618, one of the largest black holes ever recorded. 64 billion solar masses, or 15,300 times more massive than Sagittarius A asterisk. Its Schwarzschild radius is 1,300 Australian dollars, or 390 billion kilometers in diameter. That's more than 40 times the distance from Neptune to the Sun. With such an incomprehensible mass, TON 618 may belong to a new classification: ultramassive black holes. The universe is truly stranger than we can ever imagine. Thanks for reading.